There it is. Oh yeah, we gotta have our start sound or whatever.
Yeah. Start things off right.
Yeah.
Did we lose Jason?
No, I'm here.
Oh, you're here. Okay. Were you keeping your head really still for a while? I thought it froze or something.
Oh, really? Sorry.
Yeah. It's all right. All right. Let's do this.
Okay, group meeting. There we go. All right. You ready?
Yeah.
Oh wow, this is kind of a weird way to do that.
Okay. Do you want me to read the first one, or how do you guys want to go about it?
Okay, now there it goes. Now it lets me in. Cool. Whatever. You can read one. I'll read two.
Sure. Okay. One says, deciding which hypothesis test to use. Here is a list of hypothesis tests we have studied so far this semester. For each of question 2 through 5, identify the one hypothesis test that is most appropriate to the given situation. You may use a hypothesis test once, more than once, or not at all. Oh boy. In the answer box, type in the letter A, B, C, etc. All right, so the scenario is, in an article of the Journal of Small Business Management, successful startup businesses in the U.S. and Korea were compared. One system of data compared educational level, high school, undergraduate, master's, doctoral degree, of people who manage successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis? Would that be an independent sample t-test? I'm not that good at these ones, so I really could be wrong.
I said a chi-squared test because we have the two nations plus we have the degrees of or levels of education, and so it's a multi-dimensional chart.
Oh, gotcha. Okay.
And we're just looking to see if they're dependent or not.
Okay. And so we just type in H?
I believe so. That's what I did.
Okay. So
All right. You want me to go to 3?
yeah.
A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old and younger, and 40 years old and over 40 years old. They also reported the number of employees in each group that were terminated. You want to determine if both age groups were treated equally, which hypothesis test would be the most appropriate for the analysis.
Is that the independent sample t-test?
I
Sounds
said
like a no.
It wouldn't be paired, right?
no. Let's see. Let me make sure.
I really hate these questions.
I know. I said a test of 2 proportions.
Oh, okay. I was looking for something that had 2 in it.
The percentage of employees in both those groups.
Makes sense.
2 proportions. So it's a category. I'm looking at that thing, where that chart they gave us. So I'm just trying to understand. So that would mean it's a categorical test, right?
Let's see here. Of employees in two groups. Yeah, I think so, because we're measuring if they were
Okay.
they were let go or not, I guess.
Okay. So let's see. Which one was that? Test of true proportion G?
G, right?
That's
Yeah.
what I said. I don't know if it's right, but
Yeah, that seems right. That seems good.
okay. Number 4 says a student project compared the effectiveness of two
Wait.
different.
Hold on, that's five. We're on 4.
Oh, we're on 4.
A
Oh,
survey was conducted.
that's the wrong one. A survey was conducted. Sorry, I was looking at my paper and it says 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be appropriate for this analysis? And I said a test of one proportion, F,
Okay.
because that's what we're checking.
Okay.
We're taking 248 over 2406.
Okay. Yeah.
Well, sorry, that was wrong.
What's wrong?
Sorry, that'd be 152 over 248, but that doesn't matter. Anyway, sorry.
Yeah, it's just calculation. Okay.
All right. 5 says. It says a student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open, which hypothesis test would be most appropriate for the analysis. Oh man. Would that be paired or independent samples t-test, one of those?
Yeah, I said paired sample t-test because it's the same person doing both locks.
Mm.
And so you would pair those together to do the check.
So the same person's doing each study, is that right?
Yeah, so it says that they took 25 students. Each student was given the combination to each lock and asked to open the locks. The time it took to open each lock was recorded.
So we're saying that it's paired because the test it requires that it's the same person, like it's dependent on it. It's
Yeah, I think
so. Okay.
Each of the times is dependent upon which person is doing it.
Okay.
Sweet.
All right.
All right, number 6. Deciding which confidence interval to use. Here is a list of confidence intervals we have studied so far this semester. For questions 6 through 8, identify the one confidence interval that is most appropriate for the given situation. You may use a confidence interval once, more than once, or not at all. If the answer box type in letters A, B, 3, B, C, blah, 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 whatever. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
Okay. Well, first off, is that quantitative or categorical? Which confidence interval? Well, that would be categorical, right?
And classifying the two that each one used, right? There's a set number for each one.
Yeah, I think that means it's quantitative.
Oh, quantitative.
Because we're looking at the actual values that they gave, and then we want to see if they're the same.
Okay.
So we're actually looking at the numbers themselves, not the proportions of responses. I think.
No, that makes sense. So they're each doing the exact same number.
Then wouldn't it be ANOVA? Oh wait, that's not even an option. So I
Not
guess
even an
not.
option.
There's no confidence interval with ANOVA.
Okay.
Well, it's not one sample because we're looking at two different samples, right? So it's not those.
I think so.
And it's
So what
not. I don't think it's
Maybe
yeah,
paired?
I think it's either paired or confidence interval of two proportions.
Well, or it'd be independent sample t-test.
Oh yeah.
So D?
Um,
Or maybe it's different.
yeah, I said that it is paired because you're going to have each. So it says that the banks evaluate 6 properties that both appraisers had valued. So they're looking at the same property for both appraisers.
Oh,
and
so
then
it depends
what the value
on.
is, so it's paired by each of those properties. They're dependent on each other.
Okay.
That makes sense.
So paired sample t-test. All right.
All right, number 7. In a Wall Street Journal article on the satisfaction with career paths, the percentage of psychology majors reporting that they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
Is that independent samples t-test?
Let's see. Okay. No, because this is categorical, right? Because it's saying if they're satisfied or not.
Oh, gee. Yeah, that's right. Okay.
And so I mean, they're E or N.
Okay.
And we have information on psychology majors and accounting majors.
So to proportion?
Yeah, I think so.
So F.
Man, I'm worried. This isn't going so well.
I don't know how this is gonna go tomorrow.
Oh, does it open tomorrow?
Yeah, I'm 0 for 6 right now.
Oh, gee, man. I'm right there with you.
I got the first one right though.
Well, you don't know if it's right yet. That's just what I got.
Well, I'm saying the very first one I actively participated.
There you go. That one I hope is right.
Oh
right.
God.
Gee, okay, so 8 says double stuffed Oreos. Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling among the double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? Okay, so first off, this is quantitative, right?
Yes.
Because we're dealing with the amount of film. Okay.
Yes.
And does it say that the sigma is known or unknown? Or does it not even say?
Looks like we don't have it. I mean, unless they've given it to us, we probably would assume it's unknown. Which they said it's not. They didn't say that it's known, so we can probably just assume it's unknown.
And the people doing the study, it doesn't depend on anything. Like, Well, the Oreos are in the study. I don't know if it's dependent or independent. Those I don't know.
It probably would be not be paired because the actual pairs themselves aren't dependent. So you're not going to take one Oreo that's normal and one Oreo that's double stuffed and know that those two go together.
Okay. So independent samples t-test?
So see, that's what I'm not sure on this one because I thought it was either that or B because it says that we want to find a confidence interval to estimate the true mean filling amount of the double stuffed Oreos in order to compare it to the filling amount in regular Oreos. So it kind of sounds like all we're doing is a confidence interval for the double stuff.
For each one, right?
But then we're comparing it to a known mean for the regular Oreos, if that makes sense.
Yeah, I see what you're saying.
So they kind of, I don't know, to me they kind of both made sense because, like, well, we want to figure out the mean for both of them. But the thing is we're not, the test that we're doing is we're not seeing if they're the same. We want to see if one equals twice the other. And as far as the things we've been given, we don't necessarily, I mean, we know how to do it, but we haven't really been shown how to do it. Makes sense?
Oh, man. So
our alternative hypothesis would be that P equals 2, so P1 equals 2 of P, well, I guess 2P1 equals P2.
Okay.
So we haven't really done anything like that before, so I'm assuming we're assuming that the single regular Oreos we have a known mean for, and we just need to find a confidence interval for the mean that we found for the double stuff.
So you're thinking it's B, one sample t-test?
Yeah. Oh, yeah. So above that it says you take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one.
Oh, and we're not doing that for the others, huh?
Yeah, we never measured the regular Oreos. We're just assuming we have a known mean. So we're only one sample.
So B for sure, I think.
Yeah, so I think it's a one sample t-test.
Okay. Man. What are we? 0 for 8? Gee, okay.
Think about it.
Yeah.
Okay, they get a little easier, though.
All right. Which one of the following best defines the notion of the significance level of a hypothesis test? The probability of rejecting...
Hey, we just scored. U.S. just scored.
Oh, dang it, it's done. I totally forgot. I got to record that.
Yeah.
All right, I'll finish my test. We're playing Germany. You're playing Germany, right?
Yeah.
When did it start?
5.
Wow.
We're at the 69th minute right now.
So I'm assuming she jumped the other way. I'm assuming we got to kick that because there was like a card or something, a foul or I don't know.
It was a penalty in the box.
But Germany just took one a little bit ago and they missed it.
Yeah. Germany just barely had a PK and they missed theirs. And
my gosh.
Yeah.
Hey, listen, if you miss a penalty kick, you're not good. That's like a free goal.
Oh.
My wife just said I'm really not good then. Just kidding.
No, I don't mean to be rude. I'm sorry.
He's fine.
I should have put a clause in there.
No, that's fine.
Oh, that's funny. Okay, so which of the following best defines the notion of a significance level of a hypothesis test? So the first one, the probability of rejecting the whether it's true or not, the probability of observing a sample statistic more extreme than one actually obtained, assuming the null hypothesis is true. The probability of type 1 error or the probability of type 2 error?
I think it's type 1 error.
That's what I said.
All right. So on every test we've taken, and on a lot of other things, there's always this one question, and it's like, Well, you know what? I'll just wait. We might even come across it, but
I think
it's
it's
about
number
yeah. I hate it.
11. Yeah, I
Yeah.
went and looked that up, and I was like, okay, pretty sure this is the answer.
Yeah. So we'll get there, I guess. Do I
Cool.
read this one or?
I'll do it. Sorry. Which one of the following best describes or defines the notion of p-value of a hypothesis test? So this is the one that the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Okay. Yeah, this is really bad. But okay, so just remind me real quick. The p-value is like alpha. It's usually 0.05.
Uh-huh.
And then wait. Sorry, I'm getting confused. Wait, what is the p-value again?
So the p-value is in correlation to a particular like sample statistic. So it has a z-value, right?
Yeah.
Score, which means that you had an actual value that you observed. So that's what it's talking about. So you're saying like, okay, say that I observed 2.4 or whatever. What's the probability that I'm going to find things more than that? And so essentially what you do is you take that 2.4, find a z-score for it, and then in the normal probability curve, you put that z-score in and look at everything to the right of it to say, well, it's really more extreme, so either right or left, depending upon if you're looking at things greater than or less than. And that's what the p-value is saying, what's the probability that you will find that the next value or another value that you get is going to be either more or less, depending on which test you're doing, than that value that you're looking at.
And we find it by plugging in our z-score in the applet, right?
Yep, and then shading either left or right, depending on if we're testing for p greater than or p less than.
Okay.
Or not equal to, I guess we do both.
Sweet. Okay. 11 says, suppose you create a 95 confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Okay, so it says 95% of the data are between 10 and 20. 95% of the sample means are between 10 and 20. There's a 95% chance. This one is wrong, right? Whenever they say there's a chance. I
think that one is wrong.
Okay. The 95% of all 95% confidence intervals actually contain the true mean.
That was just too confusing to mean anything.
Yeah. So I think, is it the second one? 95% of the sample means are between 10 and 20?
Yes, I'm pretty sure that's the one.
Okay.
We'll find out.
That's confusing. The 95% of all 95% confidence intervals. That's just like too many Christmas.
I don't even know what that is.
Yeah.
I don't know what that's saying.
Hey, on number 10, which one did we say it was?
The probability of observing a sample statistic more extreme than the one actually obtained.
Okay, I thought so. I just wanted to make sure. Okay, number 12. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.30 or 30%. What is the mean of the distribution of the sample proportions? 30, 70, 0.70, or 0.30?
So assume the unknown population proportion or percentage of people in town investing. So is it just 0.30? Or wait. What is the mean of the
distribution of the sample proportions? Assume that the unknown population proportion or percentage of people who invest in the stock market is 30%.
So is it 30 because it's 30 out of 100?
The population would be 0.30, right? So it's definitely not that. I would think, well, I would think it would be 30, because it'd be 30%, right?
That's my guess.
I think it's 0.30.
0.30?
Oh, is it the population proportion?
Yeah. So the
Is it just
distribution of the sample proportions, that's p hat, and the mean of p hat is p.
So it's just the same thing then, huh?
So it's just P.
Yeah.
Okay.
So it's 30%, but that's 0.3,
Okay.
I think.
So what does it mean? So it's not saying to times that by 100 to get 30, right?
Yeah, it's not saying that.
Okay. Okie doke.
I don't think so.
All right, who's up for this one?
I guess it was just confusing to me that
Maybe it is,
It's
though, I don't know. But
that P equals 0.30 or 30%, and then they're saying what's the distribution sample proportion, and we're basically saying that distribution, the sample proportion, is the same as P equals 0.30. So it's the same number. I guess.
I think it's kind of like you know, X bar and then what, mu or whatever? Aren't those usually the same or something like that? I don't know. I'm just forgetting all of this stuff right before the final.
I'm lost, so.
Okay.
What is the standard deviation of the distribution of sample proportions? 13.
Here, let me look that up real quick. Okay. Is it the equation where it's wait, let's see. Is it like the square root of p times 1 minus p over whatever? Over
yeah,
n or something?
over n. Yep.
Okay, so we know that p is, what, 0.3?
0.30, yeah.
Okay, let's see. So under the square root thing, I get a negative number. So let's see. Wait, 0.3 minus 0.7. No, it's times.
Yeah, it's 0.3 times 1 minus 0.3. So 0.3 times 0.7.
So it's the square root of 0.0021, I think. Is it 0.046 rounded? That is an option.
Yeah, 0.046.
Yeah. Is that what you got, Bryce?
Sorry, somebody's calling me. So that was yeah, I got 0.046.
Cool.
Yeah. Cool.
Then what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Okay. So let's see what that equation is. Okay. So would that be the equation 0.25 minus 0.3 over the standard deviation thing?
Yeah.
Okay. Then we need the applet. So when it says what is the probability, it's asking for the p-score. Right? We want more than or less than? Less than. All right. Wait. Is there an option for 0.1385?
If you don't round it, 0.138, yeah.
Okay. That's what I got.
That's what I got too.
Cool. So is this game being played in Germany?
No, it's in
Canada.
Oh, it's in Canada.
Yeah, my wife turned it off, man. As soon as you said that, I was like, I'm going to turn it on real quick. And then she turned it off.
Like, you're getting distracted.
I just paused it. As soon as I turned it on, I just paused it so I could watch it when we were done, you know?
Oh, right, right. So are all the games in FIFA for, this tournament, are they all in Canada then?
Yeah, this one they are, yeah. I think so, right?
Oh, jeez, we just scored.
Who did?
U.S.
It was a beautiful goal.
Man, gosh, dang it.
Sorry. Wait, maybe we shouldn't tell you because you're going to watch this later, right?
Who scored that one?
Replay.
Oh.
Boom. That was a cool one.
Gotta take a break. In the air, man.
Yeah.
84 minutes, huh?
Man, she did a backflip and everything. No, I'm just kidding.
She did a backflip.
Double McFurley.
All right. Who's got the next one?
I'll read it. We're for questions 15 through 19. Use the following information. A cupril is meant to control hypertension. In clinical trials of a cupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received a cupril. The 579 students or subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 578 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking accruprol. Let P2 be the true proportion of the people who experience dizziness but do not take accruprol. Create a 95% confidence interval for P1 minus P2.
All right.
Acupro. Acupro? Is that how you say it?
Yeah, I don't know.
Something like that.
So is 579, that's the placebo group?
Yeah. The smaller number is the placebo group. And only so 15 out of 579. Somebody's not happy.
Yeah.
Oh, this can be done in our spreadsheet, huh?
Yeah. Yeah, I just do it in the spreadsheet.
Gee, what am I thinking?
Go spreadsheet.
And let's see, quantitative distribution. Is this the quantitative descriptive statistics or inference procedures spreadsheet?
This one is inference
Inference.
because it's a proportion.
Okay. All right. So this is a 2-sample t-test?
Yep.
Wow. There we go. Got one right. Okay.
You're on a roll.
I know, man. Okay. Okay. Yeah, I'm doing it wrong. Okay. So, you know where it says variable 1, variable 2?
Uh-huh.
What do they want us to plug in there? Like,
Variable 1, variable 2.
maybe I'm in the
It
wrong...
says x1 and n1, x2, n2.
You know what? I think I'm probably in the wrong...
Are you on the Oh, sorry. This is the categorical data analysis. I think I said the wrong one.
Okay, that explains why
I think
it's not working out here.
I think I heard quantitative data analysis one, and I was like, yeah, it's not that, so it's got to be the other one.
So this is categorical.
Yeah, it's the categorical data analysis.
Okay.
Okay.
Sorry.
Oh, here we go. Okay, so it was what, 16 out of 1560 something? 1563?
Yep. So 61 out of 1563.
Wow, I'm really surprised I remembered that. Yep, 5, 7. Okay. Did you guys get negative 0.003 and positive 0.029?
Yep, that's what I got.
And does it say anything about a 95% interval or anything? Yeah, it does.
Yeah, it says create a 95% confidence interval.
Cool. Okay. All right. Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Let P1 be the true proportion of people who experience dizziness while taking acupril. Let P2 be the true proportion of people who experience dizziness but do not take acupril. Use a level of significance of sigma equals 0.05. Okay. Let's see. So is it they equal each other and then they don't equal each other? So P1 equals P2 and P1 does not equal P2?
Yep, that's what I said.
So, for example, like for 15, how did we know it was even categorical? That's something I missed.
For 15.
Yeah, like, let's see, what's the exact question? It's saying, because like when I read that, I would think, okay, it's for sure quantitative because we're talking about numbers and those numbers can be compared and whatnot. You know?
Yeah.
Like
See, that was kind of confusing the way they explained it at the beginning of the semester and then the way that we're talking about it now, because numbers are always involved.
Yeah.
The difference here is that what we're looking at is proportions. So there's percentages involved, basically, where we're looking at the way that we know that it's categorical is because we have two categories and we're looking at what percentage fall into a particular category. So here,
Okay.
we know that we have an entire population of 1,563, and 61 of them were affected by dizziness. And then we have another population that's another category that, or has two categories as well. And those categories are they were either affected by dizziness or they weren't, right?
Yeah.
So we're dealing it's more that we're dealing with proportions, and that's what we call categorical, I guess, which is kind of confusing because at the beginning of the semester they didn't explain it that way.
Right.
And so does kind of seem to be a disconnect, at least the way that it's explained.
Okay.
So really, I mean, the thing is everything we've learned about categorical data is all dealing with proportions. And so if a proportion is involved, it's probably considered categorical.
All right. Okay.
So we're on 17.
It asks for what? The t statistic, right?
The value, yeah, the t statistic.
The test statistic, yeah.
Is that just asking for z-score or?
Well, kind of. Yeah. It's asking for the z-score.
So is that 1.458?
Yep.
And then the p-value of your test for 18.
0.928?
I got 0.145.
Oh. What did I do? Okay, so type of test, that's probably where I'm off.
Yeah. We said it was not equal.
Not equal. Okay, that changed it to 0.145.
Yep.
Good thing that was not fill in the blank. Okay. So there's not going to be sufficient evidence. We already know that, right? Because it's 0.145 is greater than 0.05.
Yeah, 0.5.
So no, I failed to reject HO.
Okay. Almost halfway done.
Yay.
This thing is long, man.
Yeah, I feel like the last one was more brutal to us. We didn't have Bryce there.
Oh yeah, that was true.
Yeah, that was so bad. Hey, but we still got like a B plus on it. I mean, it's not bad.
Yeah, we got 88, right?
Yeah, something like
88
that.
or 85, something like that. Yeah, it was good.
No.
Just very long.
Just very long. Yeah.
Okay.
All right, I'll read it. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? I'm a night person, by the way. The hypothesis for the studies are HO, being a morning person or evening person, is independent of age. And alternate is being a morning or evening person is not independent of age. The results of the survey are given here. Use this table and the information above to answer question 20 through 23. Conduct a test of independence. Use a level of significance of A equals 0.05. Calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied.
So we gotta use our good old chi-square, right?
Our cheese square.
Okay.
I love how I called it, what did I call it the other day? And you guys just, I called it something
square?
else. No, I called it something else.
I forget.
And then I was like, oh yeah, I'm an idiot. That's basically what I was telling myself afterwards.
I don't remember that, so apparently it wasn't too bad.
Well, that's nice of you, because I remember it.
Cool.
So I'm assuming that the girls won, right? So already over by now.
Yep. 2-0, right?
Yeah. So what does that mean? Is Germany out, or are they gonna
Yeah,
go
they're
for
out.
Germany's out.
Yeah,
The
it's
US
a
is going
single.
to the final, the championship.
So Germany's gonna fight for third place or what?
Oh yeah, that's right.
Yeah. I guess they're not out, but they can't be first or second.
Right. Yeah, they're playing for the consolation, right? So, who did Japan beat England?
I don't know.
Or maybe they haven't played yet.
Who else playing? You know?
Yeah. Well, Japan plays England.
Oh, have they played yet?
I don't think so.
Oh.
But US is ranked higher than both those teams, right?
Yeah, they were.
I don't. Are they? I thought Japan won last year.
No, US won last year.
Not last year, last one.
No. They won the Olympics. The last World Cup, they did not win. Japan won, I think.
Oh, maybe it was the Olympics. Okay.
Yeah, the U.S. women, they won the Olympics.
Oh, okay.
So I don't think they played yet.
That makes
Yeah.
what everybody else was saying. What sense though?
Just to let you guys know, for 20 I got 6.58 for the test.
6.580.
Oh,
Yep.
yeah.
I got.
Cool. Yeah, they play tomorrow. Sorry, they play tomorrow. Japan and England plays.
Cool.
Sweet. What? Let's see.
And then 20. Are you guys ready for 21?
Yeah.
So it says calculate the p-value for the hypothesis test.
For p-value, I got 0.0866, and I don't see that.
Yeah,
It's rounded.
7.
Oh, 87. Yay. Okay. There we go. Then should you reject the null? No.
Greater, right? It's greater, right? So we would not.
Yep.
So should you check? So you say no, the p-value is greater.
Greater than 0.5. What will you conclude based on your results?
So the null was, or no, we stick to the null. Being a morning or evening
We
person
have
is
insufficient
independent.
evidence to say that the alternative was true. Right? Well, right? We have insufficient evidence to say that being a morning or evening person is not independent.
Right. Right. Yeah.
Okay, right.
Cool. And then use the following information for questions 24 through 30. A recent book noted that only 20% of all managers outperform the Dow Jones Industrial average over a 5-year period. A random sample of 200 investment managers that have graduated from one of the top 10 business programs in the country who followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, a 95% confidence interval of P is... Okay. So
what type of test is this, first of all?
yeah, that's what I'm looking at. So is this the two-sample z-test for proportions?
Wait, what? There is no two-sample z-test.
Well,
Gotcha. Yeah, for proportions. Yeah.
okay.
I was like, there is no z. Like, we
Right.
pick up on z after we got finished doing one.
Yeah.
Gotcha. Yeah. So it's
So for x1 and n1, I know that it says 20%. Are we just gonna say 20 and 100? Is that how it works, or what? I mean,
well, you only have one proportion there. You don't have two.
so then is this the wrong spreadsheet I'm looking at? Like the two proportions one, is that?
You're in the right spreadsheet. You're on the wrong tab.
Oh, gotcha. One proportion. There we go.
There you go.
And it was 50 out of 200, right?
Yeah, one sample. Oh, there you got. Yeah, that's where it is. One sample z-test for proportion. Yeah, that's the one.
And our null hypothesis is 0.20. And we think it's the type of test that's, what was that?
We don't know that yet, because you don't need to know the type of test to find a confidence interval.
Okay. Then I got 0.0306 and 0.0283.
I got 0.190 and 0.310.
Okay.
What did you use as your x?
50.
Okay, and then your n?
200.
Okay.
Confidence was 0.95 and null hypothesis was 0.2.
Yep, that's right.
Yeah.
And mine's on greater than. Maybe it...
Yeah, that's what mine is too. That's what it ends up being. Wait, so what did you say you got?
0.0306.
Oh no, you're looking at the wrong thing. That's the standard deviation of confidence intervals.
Oh, whoops.
The
Okay.
confidence intervals, the next box is down.
Okay. 0.19 and 0.31.
Yeah, that's the one.
There we go. Okay.
All right. Suppose you've been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with a 95% confidence? Use the prior estimate of P. equals 0.2 for its estimate.
And I don't think we could use this spreadsheet for that, huh?
No. Well, I changed it so that it does what I want, but no, so the equation I think was in, I don't remember which lesson it is.
Where?
Yeah, it's
Lesson 17.
Okay.
Okay.
Okay. You said it was lesson 17?
It was lesson 17. That's not the answer. I was saying it's in lesson 17.
Yeah.
Okay.
I'm just looking for that. It's oh, here we go. Is it the n equals z star thing over m squared times p?
Yeah, that's the one.
Okay. All right. So for the I forget what it's called, but the z with the little star, we just have to write down or have one of those charts handy. Like there's no.
Yeah, most of the time whenever we're doing this, most of the time we use 95% confidence interval. So we know the z value is going to be 1.96.
Okay.
Because that's, if you remember, you put that z-score into the applet and then you shade above, and that's what the area is, or whatever.
Right.
Shade below.
Okay, let's see.
Or no, you'd shade in the middle. There we go.
What was p star? It was 0.02? 0.2?
Yeah, 0.2.
All right, I got, let's see if it's even an answer, 1,537.
Yep, that's what I got.
Sweet. Took a while, but Got it. One minute.
Okay.
Okay. 26, right?
Yep.
Okay, it says, suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use this level of significance of 0.05. Which of the following pairs of hypothesis is the most appropriate for addressing the question? So is it the third one where it's P equals 0.2 and P is greater than 0.2?
Yep, that's what I said.
All right. All right, who's got the next one?
Number 20. Let's see.
27.
27. Okay. How many measurements must you have in order to assure that p hat is normally distributed? So this one was a little confusing because of the way it's worded, but I said that it's np greater than or equal to 10 and np minus, or n minus 1, sorry, n times 1 minus p greater than or equal to 10.
Yeah, I think that's right.
Because, I mean, you could figure out what n's supposed to be, but not any of those are even right, so.
Yeah.
Right.
Yeah. Okay.
28. The value of your test statistic is
Okay. So we need to find what P, or the Z score thing?
Yeah, and you can just throw it in the spreadsheet. Actually, you should already have it, I think. Yeah, we already put that information in.
Oh, cool. 1.768?
Yep. I'm blow my nose. And then the p-value should be there too.
Oh, wait. I actually didn't put that for the P-value. All right. For the P-value, did you get 0.077?
No. What do you have your type of test set at?
Let me see. Oh, it should be greater than, right?
Yep.
So 0.039.
Yeah, that's what I got.
Right.
And then, let's see, so 30 says, is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? And I said, yes, I reject the null.
Yeah.
The p-value is less than the level of significance. Cool. So these next ones are actually in the homework.
Yay. Now, which homework exactly would that be?
Let me remember. So this first one is the one that talked about the blue scores of a computer program that translates 100 blocks of text. I don't know if you remember that.
Blue scores. Oh, that was a while ago, right?
Yeah.
Yeah.
I think. Let me see here. No, that's not it. I think it's the inference of two means that are independent. No. That's wrong. That's wrong. Sorry, inference for one mean sigma unknown. That's right. Yeah.
What week?
That's lesson 11, week 5.
Okay.
So for you guys, has this semester gone fast, slow, or just the same as always?
Slow.
It was going fast, and it seems to be getting slower and slower.
It's taunting us.
Yeah, it's just dragging out.
Fun. Okay.
Wait a minute. Oh, there we go.
Okay. 0.28 and 0.29, right?
No. For numbers. So it's number 6 on the quiz.
Yeah.
0.2. Oh, 282. Yeah. And 0.2. Yeah, you're right. I was supposed to go out to 3 or 2 decimals? 3. Okay.
0.282, and then what was the other one?
0.293.
293.
I mean, if you want, you can calculate them again or throw them in the spreadsheet again.
I would not like that. Okay. Calculate the degrees of freedom and the test statistic for a test of what that says. Okay. Let's see.
So
I quickly did that, and I got 99 and negative 2.803.
yep. All right, and then number 33 says calculate the p-value for the test. And I got 0.006.
0.006.
Uh-huh. That's what I got. I don't know.
Yeah. Same here. And so we would have sufficient evidence to say that it's different.
Yes.
So that's the third one for me, if it's the same for you.
It's the fourth one for me.
Or yeah, fourth. Oh no, it is the third one. Oh, yeah, I'm glad I said that. I actually marked the wrong one. Yeah. Whoops. Okay. Let's see. Okay. For the next one, I got negative 3.052 and 0.838.
35.
Yeah.
I got 8.728 and 10.455. Let's see here.
Yeah, I think I was just on the wrong one. You said 8.728 and what?
And 10.455. This was the same as what we did in 6, lesson 12.
The homework, right? Or group meeting?
Yeah, the homework. And then 30. Did you find 36, the T score? test.
Is it negative 22.446?
I got 22.446. Did you switch the? Where did you switch the AMs and PMs?
What's that?
Maybe it is. Let's see.
So let's see, because when I did it before, I put negative and they gave it to me as right. So perhaps either one works, right? For the T.
Maybe, yeah. Let's see. Why would that work?
Because then above that it says it's one-tailed, so that makes me think it shouldn't work. But
I don't know. Oh, well, I guess you're putting your z-score at the same, so whether it's negative or positive just depends on what tail you're looking at. So, yeah, that does make sense, doesn't it? Huh. Interesting. Okay, haven't thought of that. Yeah,
then
you
the next one, 40?
probably could do it negative or positive. Yeah, 40 for the degrees of freedom.
I don't know. No, we gotta go back. Doesn't matter.
For the next one, I got 0.000.
Okay.
0 point. Yep, all zeros.
And then yes, because we rejected the null. All right, I think that's all of them.
Cool. All right, you ready?
Yeah. Real quick, was 35 8.728 and 10.455?
So you said 38.
Yeah.
35. Oh yeah, 8.728 and 10.455. Yep.
Okay. $97.
97. Let's see.
So it was 11 we got wrong.
We missed that one.
Oh man. See, it continues to haunt me, even when we thought we had it.
Yeah. Okay, I feel like I've got that right before.
Yeah,
Maybe
no. Like, I feel like this same thing. Like, sometimes I'll get it right, sometimes wrong, and so it's like, okay, I'm not really getting this apparently.
Yeah.
So, well, 97's good. I'm happy.
So what was the right one for that one then, I wonder?
I don't know.
You said when it talks about there's a chance, it's not right.
Yeah, because they say it's either right or it's either wrong.
Wrong. It's not what if. Yeah.
Yeah, right.
So it's probably the first one because 95% of all 95% confidence. That didn't seem right to us.
Yeah, it's got to be the first.
So it's got to be the first one.
Yeah, 95% of the data lie in there. That makes sense.
So, real quick on the test, I didn't know it's actually due Wednesday. I didn't know that.
No,
Yeah.
Is it due Wednesday? Hold
Yeah,
on.
it says it's due Wednesday.
Oh yeah, you can actually start it now. Yeah, so it's due Wednesday at 10:55.
Oh man.
Yeah, so.
All right. Well, that'll be fun.
Yeah.
And so, I mean, we can't really do anything on our project till we get it approved, right?
Yep.
Yeah, it hasn't approved it, right?
Not that I know of.
Not that we know of yet.
All right.
Hopefully we'll get that soon. Hey, I've got to go run to a meeting, so.
I know
All right.
my wife's got mutual, so. All right,
Yeah.
guys.
Guys.